Hello, my name is Xander. Welcome to the Python Intermediate course. Here we're going to take a first look at Lambda functions. I'm hoping by the end of this tutorial you'll have a better understanding of what a Lambda function is and how to utilize it in your program using map, filter, and reduce. So it probably is a little bit early to start introducing Lambda functions at this point, but I wanted to get this in early so that we can, in future tutorials, explore Lambda functions in different aspects of Python as we go through this tutorial series. So while I'm talking about Python Learning series, if you're not familiar with Python basic functions, then maybe just head back to the Python beginners course before you start this tutorial and have a look at functions there so that you've got a general understanding of what a function is before you then start thinking about understanding Lambda functions. You'll find that on the Python beginners course, PY001, so go ahead and have a look at that before you start this tutorial. So just before we start having a look at some of the examples, what we're going to do here in this tutorial is first of all have a look at a comparison between a traditional Python function and a Lambda function. That's going to introduce us to the syntax and the construction of a Lambda function, and then we go ahead and write some Lambda functions for different scenarios, going ahead then using Lambda functions with map, filter, and reduce. So hopefully that will give us a grounding and understanding of Lambda functions so that we can start to utilize and explore further in future tutorials. So let's just recap the dynamics here of a traditional Python function. So we're using the def keyword, define keyword, and we have a name which then corresponds to our functions. We have a named function so that we can call it. And then our function then can take in attributes. So here in this case, we're going to take in one attribute, which is going to be a number, because we are then going to create a new function, which is going to calculate, going to take whatever we pass into our function, and then we're going to use it to then calculate, make the small, simple calculation plus 10. And then what we traditionally then do in our function is we return something. So we explicitly define our return. In this case, we want to return the value that's now stored in this variable from this expression. So now all we need to do is to call this function to perform the action and pass in some data. So here we are, we're calling this named function count, and then we're going to pass in the value of 10 in order for us to perform this calculation, and that should then return the result, which is going to be 20, and there we go. So for the sake of comparison, let's do exactly the same thing, but here with a Lambda function. Now, one thing that we can start off saying with a Lambda function is that we don't need to explicitly give it a name, and we don't need to explicitly define a return. So that's just going to happen by default with our Lambda function. Now, in addition to that, we don't actually have to call a Lambda function. So a Lambda function we can have execute without actually calling it. It is a nameless function, an anonymous function. So let's go ahead and just give you an example of that. So for this, we're going to open up the Python. If you've got Python installed, which I presume you have, open up the IDLE. That was probably installed when you installed Python. And what we're going to do here is we're going to write in the same function here, but as a Lambda function. So with Lambda, we're going to use the keyword Lambda. Instead of def, we're going to use the keyword Lambda. Oh, Lambda. Okay, so that's the first thing. So let's just take in an attribute. So here we're going to set up x like we've done previously. So Lambda, then x. So notice that we don't need the name here. This is a nameless function. So let's go ahead now and define the second part. So we're going to need the colon here. And now we're going to need our expression. So this was just x plus 10. Right, so that's our Lambda function. Now we do want to pass something into our Lambda function, of course. So this is all done on one line. So let's go ahead and just now use the parentheses to pass in something. So let's just pass in 10 again. And this is pretty much it. This is all the essence here of a Lambda function. So we have the Lambda keyword, we then have our attributes, and we can use multiple attributes similar to a normal function. We have our expression, so in this case it's x plus 10, and now we have what we want to input into our Lambda function, which is 10. And notice this can all be done on one single line, and typically you're going to be writing your Lambda functions on one line. So if I press enter, that's going to be executed and the output is 20. So let's summarize. Now, a Lambda function can have many different names. Sometimes it's dependent upon the programming language that you're using, but commonly it's known also as an anonymous function. And you've seen in that last example why that potentially is, because we can run the function without explicitly naming it. So we also saw in the example, and this is very commonplace for Lambda functions, it's written as a single line of execution. So that's the second thing to understand about the Lambda function. You're going to be writing this Lambda functions on a single line. And then finally, you've seen that it can be, or could be known as an immediately invoked function expression. So you can see that we can immediately, without calling the function, the Lambda function, we can have it processed and interpreted by Python in order to return the result. And that's what we saw here in the IDLE. We simply just run the Lambda function. We didn't explicitly call it. And notice also that the Lambda function explicitly returns. So we don't need to define return like we do with a traditional function. So that in a nutshell really is the basics of a Lambda function in one simple example. So we've seen that we've got, looking at the syntax here, we've got the keyword Lambda, we've got arguments, so we can pass in any number of arguments. So we'll go through some examples there in a second, similar to the traditional Python function. And in addition to that, what's important to understand is that the Lambda will only have one expression. Okay, so that's important. So here we're not going to potentially utilize a Lambda to convert all of our functions, our traditional functions, into Lambda functions because it only has one expression capability, and that would then be explicitly returned, the result. So let's go ahead and have a look at some more examples using Lambda, looking at the variety of different arguments that we can pass in and formats. So let's just convert this function into a Lambda function, and let's convert this into kind of a named function, if you like. So let's call this, for example, x. So essentially what we're doing now is we are taking this anonymous function and we're kind of converting this into a named function again. So Lambda, and we're going to pass in y as an attribute, and then we're going to perform our action, which was y plus 10. And there we go. So this should now be returned. So let's go ahead and do that. So similar to how we pass in our attributes to a normal Python function, let's go ahead and pass in 10. So x, and then pass in 10. So that is going to then be passed in, and then we can then perform our calculation. So let's go ahead and do that. And there we go. So you can see that we can also utilize it here, as well as utilizing it as an immediately invoked function expression. Right, so now we've got that in place, let's go ahead and have a look at some of the different options we have for attributes. So only because we haven't really touched on this very much in the previous tutorials in our Python series, let's go ahead and just showcase some of the different options we got here. So we can utilize multiple attributes. So let's go for x, y and z, for example. Let's pass in y and z. Let's do some calculations on y and z, for example. So here we just need to pass in two attributes now, and there we go. So that's just an example, if you like, of positional arguments. We can, of course, define default values, for example. So let's go ahead and try that. There we go. So we have a default value there, and then in addition to that, we can also add, for example, known values down here. So for example, this is going to be z equals 10, for example. And there we go. So in addition to that, you might also want to pass in a number of arguments all at once, for example. So if you wanted to add up some numbers, we could pass this in as arguments, args, and then go ahead and, for example, utilize sum, for example, and then grab all those numbers and then add them all up and then return the output, which is going to be, in this case, 15. Okay, so we've got args, and we can do the same thing with quarks if you want named values. So, for example, something like this. C and D. So here we could use, for example, quarks. And then we can go ahead and grab the values of our quarks. Values. There we go. We need a dot there. There we go. So we're just going to grab all these values. And I'll give that a go. We do have a syntax error. Oh, ready to find it. D and E. Nope. Quarks. Apologies. Maybe we've got some. Okay, I've forgotten the W. Right, so there we go. And there we go, 15 again. So you can see how we can pass in different formats of attributes, if you like, into our Lambda function, similar to what we can do with our normal Python function. So now we've seen a simple comparison between a traditional Python function and a Lambda function. What you're probably not going to do now is start to look at your existing program and convert all of your functions into Lambda functions. So that is because the Lambda function is written on one line and it only allows for one expression. So when would we use a Lambda function? So I promise I'm not trying to build this up anywhere. In some situations, it's difficult to understand why you might want to use a Lambda function, because the reality is our programs can do without a Lambda function. We can work around and utilize other tools to perform and to produce the same outcome. So let's go through some examples here using some built-in functions, map, filter, or reduce. And Lambda functions you may see regularly being utilized in these situations. And then we go for an example where we embed a Lambda function within our code where we couldn't normally use a function. And that then gives you and allows you to then think about how to utilize a Lambda function within your application, at least initially. And then as we go through these series in this Python series, we'll have a look at introducing Lambda in different situations and look at the benefits and drawbacks of doing so. So first up, we're going to have a look at utilizing map with a traditional function and then Lambda, and we can have a look at some of the benefits and drawbacks of doing so. So if you haven't used map before, map performs an operation known as mapping. It's going to be much easier to understand once we're doing it. Basically, what's happening here is that we're going to create an iterable, a list or a dictionary, and we're going to be able to use map to take those individual components from an iterable, numbers or letters, and we're going to iterate over it. So we're going to essentially loop over this list on every single element within the list, and then we're going to perform some sort of action, some sort of function on each of those items. And then we can return our new list or the result in a new list. So let's have a look at an example. So there's a little bit of setup here. So we're going to just go for, we'll start off with our normal function. Let's go for our count again. Let's take in x, and then we're going to use y equals, then we go for our simple calculation, and then we'll return y. And now what we want to do is we want to print. So let's just go ahead and print our count. So we know that that is going to pass in 10, add 10, and give us 20. Right, so that's a single number. So what happens if we have multiple numbers we want to perform this function on? So let's go ahead now and build a simple list. Let's call this numbers or num equals, and let's build a simple list here with some numbers. There we go. So what we want to do now is we want to perform this function on all of these numbers. So we want to add 10 to all of these numbers. And then the outcome is a new list with the numbers that we've added to 10. Right, so what we're going to do here then is utilize map. So map is going to provide us a tool that's going to allow us to do exactly this. So I'm going to call this add. So add equals, and then we're going to use map. So map is going to take in two things here. So it's going to take in, first of all, the function. In this case, it's going to be count. And then it's going to take in the data that we want to perform on this function. So map is essentially a way of telling the interpreter to take all this data here and then individually, one by one, run this function on each of these components here, or each of these numbers. And then we're going to return all of that as a new list. Right, so let's just pass in our numbers here. Okay, so we've got a function and we've got our list, our iterable. So like I said, any iterable, here we're utilizing a list. It could be a dictionary, for example. So now we're going to just go ahead and print this out. So what we're going to do here, we'll just convert this into a new list, and we'll then just define or just identify our map here for our function name, add. So that's our final code. So let's go ahead and give this a go. And there we go. So the outcome here is a new list with the numbers that have been added to 10. So this is a simple example. Hopefully, from what I've described so far, you understand. We will be looking at map in more detail in this tutorial series or this course. So this is just for a simple example so we can then showcase, in this case, Lambda, of course. So let's go ahead now and convert this to Lambda. Right, so what you're probably already seeing is this is a function. Okay, so we're just going to now create a similar function as a Lambda function. Now it is a simple function, it has one expression, so it's probably good to transfer or to convert into a Lambda function. So let's go ahead and do this. Now we're going to be utilizing map still. So we're going to still need to utilize the numbers as per normal, except for now the count, where it's referring to this function, this is where we're going to put our Lambda function. So let's put this in, Lambda. And now we know we're going to pass in something to our Lambda function. So we'll just call that x, our attributes. And now we need to know our expression, which was just x plus 10, of course. So this is now our function. You can now see it's being replaced by this function here. Now, straight away, if I remove that, the code is already looking, in some respects, there's less code, of course. Now, it's a little bit more short and sweet. And for some people, it could be easier to read. Now, for others, potentially, this isn't their preferred method. In some cases, it's just a case about preference. It's just about preference and readability. If it's something you can work with and you're familiar with, maybe you utilize this in this simple case. If it isn't, then you can see how we can also then utilize what we've seen before in our simple traditional function. So let's go ahead now and just fire this off. Now, we're just going to do that, and then we'll just wrap this up in a list here. Let's just have a one line. And there we go. So we've just converted it now into a Lambda function. Let's go ahead now and run it. And you can see that we have the same output. So in the realms of data science, you're going to probably see Lambdas used quite a lot. So it's definitely worth just becoming familiar with the general format of a Lambda so that you can read other people's code. So let's go ahead now and have a look at filter. So this is going to work in a very similar way. We're going to have the function, passing the function and a list in a filter, whereas this time a filter will filter out all the elements of an iterable, for which the function returns true. So that might not make sense at the moment. Let's go ahead and have a look. So here, all we need to do first is remove map, type in filter. So now we're going to use a filter. So what we're doing essentially here, the word filter, we're going to filter this list or an iterable. So we want to remove from this list things that we don't want or that we want. And what we're going to return here is the items that we want to see or printed out. In this case, what we want to do is just filter out all of the odd numbers. So we only want to return even numbers, for example, in this case. So let's go ahead and do exactly that. So let's use the modulo maybe in this case. So x modulo, sorry. There we go. 2. So whatever this is, divided by 2 in this case. So 2 in this case divided by 2, that's going to give us the remainder of 0. Okay, so wherever there's an even number here, we're going to get the remainder is going to be 0 from x modulo 2. And that's going to give us and return all of the even numbers. Now, this is obviously being utilized against all of these numbers. Okay, so similar to map, filter is going to basically take in our iterable, in this case, our list here, and it's going to utilize every single number. It's going to pass in every number here to our Lambda. We're then going to evaluate our expression with this new number. If we return true, So if we return 0, if it's an even number, it's going to return 0 in this case. So if we return true, then what's going to happen here is that it's going to then be printed out. Okay, so this is going to return true. This expression is going to return true. For every number it does in this list, or the even numbers, it's going to actually then be printed out. So we're going to filter out all of the odd numbers. Now, I apologize if I've embellished that a bit. Hopefully that makes sense. So let's go ahead and have a look. And there we go. So now we've returned 2 and 4. Now, obviously, this is just a small scenario, a small example of something that can be scaled and utilized in different situations. Again, maybe in the data science area, you'll probably see this utilized quite a lot. So you may also utilize or see Lambda being utilized with, for example, reduce. So reduce, if you haven't used this before, it's just a good point to introduce reduce if you haven't used it before. It's a technique or a mathematical technique commonly known as folding or reduction. It's just handy to know all these different tools that we have available in case one day you might utilize it. So probably very much a data science type of function here that you might want to utilize, or when you're utilizing or working with data. This is going to allow us to continually apply a function to a sequence. So it's going to return a single value. So let's just have a look at it first, and then that will make it easy to understand what it's performing or how it's performing. So first of all, let's just get rid of some of this. We're not going to need a list because we're just going to end up with a single number here. We're not going to be utilizing filter. So let's go ahead and bring in reduce. So we're going to need to import that from the func tools. So let's go ahead now and bring that in, functools dot, and then reduce. Okay, right, so what we're going to need here is a sequence. So we're not going to use these numbers. I'm just going to, in this case, use a range. So we'll start off with a small range, 1, 2, let's just do 1 and 2, so 3. So this is going to be a range of numbers 1 and 2. Okay, so we're going to pass that into our Lambda. So we're going to need we're going to pass in 2 attributes here. And then all we're going to do with this is just x plus y. So what's going to happen here, like I said, it's going to reduce. So the numbers that we're working with is 1 and 2. So 1's going to come into this Lambda. Now we've got 2 parameters here. So what's going to happen is that 0 is going to be represented here initially with x, and then the 1 here is going to go into y. So we're going to start off with 0 plus 1. So the outcome of that is 1. So now 1 is going to be placed within x, and then we're going to take the second number from this range, which is 2, and that's going to go in y. And from there, we're going to add 1 plus 2, and that's going to give us 3. So the outcome of this should be 3. So let's go ahead and try that, and there we go. So that's just literally just giving us the sum of those numbers, 1 and 2. So if we want to scale that up, of course, 10, that's going to give us a number of 45. So this reduce function is going to perform this function on every single number in the range. So one thing we might say about utilizing lambdas in Python is that the syntax is more concise than if we were to kind of convert this back into a traditional function, for example. So that's potentially one reason why you might want to use a lambda function. But let's move on to the last example. So going back to this slide here, why or when. So the last point here was to use a lambda to embed a function within our code where we couldn't a normal function. So let's just provide you an example of that. So let's take a look at our previous function example. Here we have our simple count example again, where we're just passing in our number 10, just doing some simple addition and returning it. Right, so for example, here we could add a lambda function. Now remember, a lambda function can be utilized where maybe a normal function couldn't. So although this may not be the best practical example, it just showcases the fact that we can now think about potentially using a function where we couldn't normally. Right, so that was the main point. So let's wrap this up so it can then be performed. We can pass in some data into this function. So let's go ahead and add a lambda function here in our return. So what we're going to do is we're going to take our data that's been processed within our function, in our body of our function, and we're going to add, or we're going to change it in some way. So let's go ahead and create our Lambda function as per normal. So we're just going to pass in one attribute here, which is going to be the number that's stored in y. And then we're just going to perform an additional task. So x plus 10 again. So we're just going to add 10 to it again. And then we're going to pass into this y. Okay, and there we go. So what we're going to have now is an output of not 20, but it's likely is going to be 30. So let's give that a go. And there we go. So hopefully that gives us a good starting point now to explore Lambda as we go through this series. For some people, Lambda or utilizing Lambda is a matter of expressiveness of the code. So when writing code that other people have to support, that code, some people's suggestion would be that code needs to tell a story in a concise and easy to understand manner as possible. So sometimes the Lambda expression it can be more complicated than understanding a normal function. Other times it can be more direct and tell what needs to be told in a smaller, concise way. So in a lot of ways, it's about utilizing your judgment when writing your code, as and when you might want to use a Lambda function. Fantastic. So I do hope I've given you enough information. Now, some of you may be thinking it didn't go into much detail, or there should have been more detail here. I'm trying to tell a story as we go through these Python courses. Now, I'm taking into consideration here that I'm assuming that the viewer of this tutorial has been through potentially the first course and the Python Beginners Plus course. So I've got a gauge of potentially what it is you understand, and that's how I've tried to present and convey the information here in this tutorial. Now, some of this is a little bit open-ended, and I'm expecting potentially for you to now think about what was said and told, and for you to go off now and explore a little bit more about Lambda functions if you want to. However, like I said originally, it now gives everyone who's seen this tutorial, so that when we go and move into the later tutorials, I'm kind of assuming now that you have a basic understanding of Lambda. And if you don't, I can refer you back to this tutorial just to get you to a point so that you can understand what I'm talking and what I'm trying to convey in other tutorials. So thank you very much for listening. Hopefully it was useful, and I do hope to see you in another tutorial. Thank you very much.